I am Srivardhan Akula, and today I will talk about how we used computer programs and big data to help find out if someone has PCOS. Generally, the PCOS means polycystic ovary syndrome, which is a health problem many women face. We use a tool called Apache Spark that helps us work with the large amounts of data quickly. Now we can see the abstract where the androgen disorder polycystic ovary syndrome exists as a complex disease that affects numerous women worldwide. To treatment and management must start immediately after an accurate detection and diagnosis. Where PCOS is a hormonal problem that affects women, like it's hard to detect early because symptoms are different for everyone. Our goal was to use smart computer models to find signs of PCOS in healthy data. This can help doctors make better and faster decisions. So, for the introduction, if you see this, PCOS is a polycystic ovary syndrome, as you know that, because it is a multifactorial disorder of the hormonal nature and a major cause of a reproductive medical problems in women of reproductive age. Generally, the PCOS can cause problems like irregular periods, weight gain, and difficulty getting pregnant. It's also linked to the diabetes and heart disease because symptoms can vary a lot. It often goes unnoticed. That's why early detection is important and computers can help with that. For these symptoms, for this syndrome, like it because of symptoms complexity and variability, it is often underdiagnosed and diagnosed late. So generally the problems can the most common causes like female infertility with connections to the metabolic complications such as type 2 diabetes, cardiovascular disease, obesity and insulin resistance itself. So we have done some amazing related work where over the last few years there have been various interests from leveraging the machine learning and big data analytics to revolutionize the diagnostics of disease like polycystic ovary syndrome, which is PCOS. So, like there are many researchers have tried using some computer models to understand the health issues, and they have looked at things like hormone levels, lifestyles, and test results. So, and we wanted to go further by using a big data tool, which is Apache Spark, that lets us to work with much more data and faster. Where if you go to the methodology, where in this project the methodology was compromised of an end-to-end data pipeline which includes data collection, data pre-processing, exploratory data analysis, feature selection and hypothesis testing by means of Apache Spark. And this project is wholly based upon the PCOS dataset which we have taken from the Kaggle, where we followed some clear steps. Like then we cleaned it and we changed it into a format computers can understand. Like, and we used some Apache Spark to do this quickly, and after that we picked the most important features and tested our models. Like we have used some logistic regression, random forest classifier and SVS. And also let me see you, I can explain it by my code. In first step, we should upload a data set, and where I'm doing this in Google Colab, where we have to path, and where you can see that the data set is saved in this, and then we have to start the Spark session. So that's why I told you, right, like Apache Spark we have used in this code. Then if you run this, you can get, and then we have to load the data set where we have already saved the data set. So so we have, what we had is like we have to get top 5 rows which usually the problems are facing. Like we have taken age, BMI, menstrual irregularity, testosterone level, antral follicle count and PCO diagnosis, where you can see that top 5 rows where you can see the values of like what the data set is showing. And then we have to clean the data where we have cleaned the data. And like we have here we have handled the missing values. We use some isnal some to detect them. Then we either drop irrelevant columns like patient names or filling missing values if needed. Clean data helps us in better model accuracy, where you can see this. And in the next step 5, we have convert categorical columns, and where you can see that we have added some indexer fit and a transform, where we can transform the data into what we have required. And in step 6, where we have some pandas conversion ide, where we have used by importing essential libraries such as pandas, numpy, matplotlib, and seaborn for data handling and visualization. For modeling, we have used some machine learning libraries from sklearn. So here you can see that we have some data visualization, where we to better understand the data, we create some histograms, pair plots, and a heat map showing that it is like a correlation between the features. For instance, For instance, we check how strongly features like LSH and FHS ratio follicle count will correlate with POSIS, where you can see that x-axis is like where we have taken the top 5 rows which we are getting the most problems. So it is the one of either. So you can see them some scatter plot, where it is like on a testosterone level. On x-axis we have taken the testosterone level, and on y-axis we have taken the BMI. And also, if you see that it is like a count plot, where you have an y-axis we have count, on x-axis we have an some menstrual irregularity, and now it is a heat map, where you can see that the heat map is like a where what the whole top 5 rows were included in this, the how much the problems we're getting. And in step 8, we have some feature engineering. We have done some Apache Spark in this. And in step 9, we use some train test split. We divided our data into training and testing sets. Typically, 80% for training. We have splitted the data set into two types, like 80% for testing, 80% for training, and 20% for testing. This helps us to evaluate how the model performs on unseen data, where you can see on the step 10, the model development. Like generally we build some models like logistic regression. We imported some we imported some models like logistic regression and random forest and SVM. These are all the machine learning models, like a SVM classifier. We know everything, and each model is trained on the training data using dot fit, and tested use using for the train. Like we have divided two data sets, like for the 80% for training and 20% is testing. So 80% of the training data we use dot fit, and the 20% data tested data we use dot predict. So where you can see that the model for evaluation, we use metrics like accuracy, confusion matrix, precision, recall, and F1 score. ROC curve. Generally, the ROC means receiver operating characteristic. This helps us to compare model performance and divide which is best for PCO's prediction. Here, with here we can see that we have done all the three models which we have compared each other. Like with random forest, we also get feature importance to understand which medically attributes are most influential. For instance, follicle count and hormone ratios are often come out on the top, where the results, we evaluated three different machine learning models on the pre-processed PCOS dataset using logistic regression, random forest, and decision tree. And also, the models were trained using Spark, Matplotlib, and their performance are evaluated on groups of data using accuracy, F1 score, weighted precision, weighted recall. So, if you come at the conclusion, where in short, we showed that smart computer models like and big data tools can help detect PCOS, and Apache Spark helps us work faster and handle more data. In future, we want to use even bigger data, real-time patient information. and my more advanced models like deep learning. Thank you.